Copernicus is Houdini's latest update to COPS 2 and was mainly used for compositing images and footages. The latest Copernicus does a lot more than just compositing. Have you ever used Substance Designer? A lot of people have seen Copernicus as a replacement tool for Substance Designer, but in my opinion, even with all the similarities between Designer and Copernicus, they are still very different applications. Designer has been around for years. It was first launched in 2010 when it was still owned by Algorithmic, before it was bought by Adobe in 2019. In comparison, Houdini's Copernicus still needs to do some catch-up before it can compete with Designer, but that's not where the real power of Copernicus really shines. Copernicus is part of Houdini. That is the real selling point. Houdini excels at physical simulations and procedural generation at levels that are unmatched in the VFX industry, and having the ability to integrate seamlessly with Copernicus makes it very powerful. In Houdini, we have SOPs, .NET, LOPNet, ChopNet, PopNet, and now for COPS, we have COPNet. We're going to start off by getting some of that juicy attribute data from the SOPs, from your geometry, and bring it into COPS. And then as a round trip, we're going to get all that and bring that data into a Karma material for a complete render. Now I've chosen this CC4 character by Reallusion, and I've modified the diffuse texture image to add these little green acne bumps as an example to demonstrate what we can do with COPS. So like I said, everything's a network in Houdini. So let's drop down a COPNet and let's get started. So this is the one that is driving the image that you see on the screen right now. So let's start with a new one. So this is only something I already did ahead of time. In fact, this character model has a very important attribute because I only want the acne to show up on the front of his face, but I don't want acne to show up inside the eyeballs or on the eyelids. Some of it is inside the mouth bag, but because this shot has his mouth closed all the time, so that doesn't quite matter too much. Now, this is the group that I'm using. So this is the area where I want acne to show up. So this is a primitive group. What I'm going to do is convert this primitive group into a face area point attribute. So one thing to note, very important, is that the attribute needs to be a float type. If you make it an integer, it's going to throw an error. COPS won't like that. Now I've subdivided this just to give it a bit more topology because I'm gonna later on feed this into a height map and it's gonna get bumpy. So this is only to have a smoother preview in COPS. It's not the one that we're gonna be using because in the end we're gonna be rendering in Karma. Again, let's throw down a new COPNet node, although I think that was a new one. Set the resolution. We can actually do this a little later, but I'll set it right now. I'm gonna set it to 1080 by 1080. I'm gonna take this and copy it over here so we have a perfect square. It will get important because we're gonna be dealing with UV squares in COPS. Now this is the geometry that we're gonna bring into COPS. So this is a very slimmed down version because we don't need all the different parts. Like in this character model, you have the hair, you have the eyebrows, and I don't believe he has a beard, but he has these sideburns and all these different geometries, the eyeballs, the eyelids. We don't need all that. We're only taking, for this demonstration, we're only taking the head skin and we're going to be modifying that in COPS. So all I really need is just the head skin model. This does not have the eyeballs. So let's come in here. Now, how do I get my geometry data into COPS? There's actually a SOP import node. Now, as the name implies, it allows us to import SOP data in here. In order to get our geometry into here, we're going to enable this and we can manually choose it. Oh, character, will be this guy. Nope, not him, because this is the entire character model. It's the other one, sorry. So that's something you have to be careful of when you're choosing your geometry. You want the geometry that you actually want to modify. And that's the slimmed down version. So let's rasterize this setup. We actually have to flatten this guy out onto his UVs. So for the workflow, I'm gonna show you, it's only gonna work if the geometry has UVs. In COPS, we're still manipulating an image, and that image is based on the UVs. The texture maps and everything, whatever you generate, it will be based on 2D. It will be based on the UVs, in fact. So let's connect this up, and what this rasterized setup does, it just flattens everything. Now, once I put the render flag here, nothing happens. Now, I'll come up here and change the position to UVs. It will pop down just because my model's not in the center position, at least the head is not. Now, the next thing we want to do is rasterize the geometry. We're trying to bring in that face area data from the point attribute in SOPs, on the geometry, and we're bringing it into COPS. So by rasterizing the geometry, let's hook this up first, this to geometry, and put the render flag here, I can start to bring in those attributes into COPS. This quick setup is really handy. Now the first thing I'm going to do is add UVs. Notice right after I added the UVs into the rasterized geometry, we get a new UV output over here. So now it's available to us to manipulate in COPS. Now having the UVs available to us right now is not too important. I really want to get the face area. So what we can do is just add a new one. What output type is our face area? In SOPs, it's a float attribute. It's a float point attribute. In COPS, they have something called mono, UV, RGB, RGBA, or ID. Mono, as the name implies, it's just a number. It's just a float. It translates to the same thing as a float in SOPs. UV is a vector 2. It's a 2D, it's an image. It's X and Y. RGB is vector 3. It's your X, Y, and Z channel. And RGBA is just your X, Y, Z plus the alpha channel. ID is really the same thing as mono, but as an integer. So that's what I was saying. It's important to have the face area. Making it a float is important. We never know. I may want to do a fall off for the face area and have it gradually increase instead of having that sharp masking area. So it's important to make it a float ahead of time. What would we need in order to access that face area? To bring it into COPS? What would it be? It would be a mono because it's a single scalar value. It's a float, and that's what a mono is. You can think of it as a black and white image. Now, instead of P, well, we don't want P, so we want face area. And again, notice down here, we create the face area. So now the face area is available for us to manipulate further. Now, I want to actually see the face area in the viewport, so I can double check just to confirm that it's bringing in the right data. Let me just throw down a ramp. We can actually do a ramp to model ramp, and this will produce a black and white image, which is, yeah, let's start with that because I want to show you what you can do with a mask. This is the one we're actually going to be using. I'm going to hook up this face area to the position. I know the colors don't match, but it will convert it. It will cast it. And right away, when you put the render flag on the ramp, you'll see the viewport update with the face area identified as white. Now, to make this mask a little sharper, what I can do is squeeze this ramp a little closer. Okay, so just squeeze this one. Now, you don't want to squeeze too far because that'll start clipping a lot more than you want. Ideally, I want all this black area to be pure black. I don't want it to be gradient. That way, it's a more useful mask. So we know that the areas that we want is pure white. There is a bit of fall off, which is really nice. I really like that. Now, this is going to be our mask data. You can generate it out. So you can render this out as an image file. It's just a JPEG image file. And when you can plug it into Substance Painter and then do all sorts of things with it. This was the feature that blew my mind because I use Substance Painter a lot. This would work with any application, any 3D application, a Blender, Unreal Engine, just because it's just a black and white image mask. You can plug it into any material system and further manipulate it. In this video, we're going to plug this mask into Karma and we're going to manipulate it there and to have a full end-to-end workflow. Let me just throw down a preview material just to show you what it looks like, what this mask looks like on the geometry. So I want to move this down, and this preview material, it needs a geometry. That's just the SOP import that we brought in. So we connect this geometry to the preview mask material. Render flag on this guy. We don't see anything. Now let's connect this ramp. That's our black and white mask. In fact, let me label this. This is going to be the face area mask. I'm going to connect this ramp into the base color. Now we see that same point group mask that I had created in SOPs. Now it looks really freaky and it's not very helpful as a black and white mask, but we can throw down another ramp, but this time an RGB ramp. Let's throw that down. It will automatically connect the ramp to this size input, which is not what we want. This is not the correct input. What we want is to connect this to the position. Let me disconnect both of them. Okay, now let's do it again. Ramp to position. It allows me to remap the black and white values coming from the face area mask onto color. Like I don't want black and white, I want actual color. That's what you wanted to do in Cops. This is how you can do it. And I'm just gonna make random colors. So you can start playing around with this and then add noise and change the hue, brightness. Use this mask as a roughness code, anything. We can actually start plugging this in. So the areas of the face mask area has roughness now, and all the black parts are shiny. So you can start to see it start to shine over here. What we can do is do another ramp and a mono ramp this time. I'm gonna flip it. Let me put this down here. I'm gonna flip this. Now, the problem is my character model is at the top and the UVs are on the position in the origin, so I have to keep scrolling back and forth. Ramp here, I want to switch this and then again this ramp is connected to that size thing. That is not what I want. I want it to connect to the position. Okay, now I'm going to connect this to the metal and let's see how this looks. Okay, so it's really shiny now, at least on the parts where you see white. Actually, we can make it more shiny by squeezing this a little tighter. So now the rest of the head is super shiny. So that's one way you can use the mask, but we're not going to be using this because Karma is a much better rendering system than this CopNet. But CopNet is really good at creating these masses for manipulating image and adding patterns and everything. So that's what I'm going to be relying on. So let's just delete this. I'm going to connect to the base color. Now, why would we have this preview material here? Why would we keep this here if Cops is not really that good at rendering? Well, it's really good for debugging. So I'm gonna color this node black. As you all know, I color all my visual nodes, all the helper nodes, the debugging nodes black. So the next thing we're gonna try and do is create those acne spots all over his face. And to do that, the perfect node to start using is the stamp points node in Cops. What this does is very similar to the copy to points in SOPs, but this is copying a pattern and it brings in points from the geometry. So we can actually define points in the SOP level and bring it into Cops and plug it into this stamp point and stamp all sorts of shapes onto it. So let's see, shape, SDF shape. So this will have a lot of basic shapes. This is the circle. There's diamond, line, rectangle. There's all sorts of weird shapes that we can bring in and instantiate it all over the points that we bring in from SOPs. In order to really make that acne look, I'm going to be using this circle. We need to convert this SDF shape into mono. SDF to mono. Because I'm trying to generate a mask. So this turns it into a black and white circle that we can then plug into the stamp. So that's the last input of the stamp point node. Now nothing comes up. That's because we don't have any points. So let's go back to the SOPs. And I actually have points defined, but they are not points scattered on the geometry. This is actually points scattered on a 2x2 grid. Now let me first show you what it looks like when I scatter points right on the geometry head. So this is the geometry head we have here. Let's start by scattering points on this and then feed it into Cops, and I'll show why I scattered points onto a grid rather than right on the geometry itself. Both works, but they work very differently. Let's do it down here so I don't have to roll all the way up and down. Come down here, let's scatter some points. This is it. I'm just gonna label this points 2. Now let's go back into cops. Now, how do we bring those points into cops? We can use that same SOP import node that we did before. That imports geometry into cops, and points is still a geometry. Okay, let's do this. Now let's find that points 2 right here. Render flag. There are our points. The thing that's different about this one is that we don't have to rasterize this because there's nothing really attached to this. There's no UVs. So even if we rasterize it, it doesn't know how to flatten it, not properly. So let's just connect this points. I'm just gonna label points. Connect this into the points of the stamp point node. Now put the render flag here. Well, this is where I started to get confused at first when I started using this. Let me go back up to SOPs. This is over here. The origin is actually down here. So we need to actually move that guy down there. At first, I was very confused. I didn't know that. And then I realized the stamp point node is actually just reading 2D values. It's flattening the points onto a 2D plane. I can show you that right now. Let's do this. Let's bring it down first. Okay, this is now in the origin position. That's good. Now let's go back to cops. Okay, we finally see something. Let me zoom out. We see a blob. That's because the circles are a little big. So let's take this scale and bring it down. Let's down-ish. Okay, now you're starting to really see it here, but it's really, really small. So let's go back to SOPs again and make the head a little larger, or the points. Sorry, let me hide this. The points a little larger. Not P-scale points though. Well, although P-scale does work, it is compatible with the stamp points node, but that's not what I'm trying to do. But anyways, I'm just trying to make these points spread out a bit larger so we can actually see it more clearly in cops. And once we come back in, we can see it very nicely here. In fact, let me break this out so we can control it inside cops without me flipping back and forth. So we can make it bigger. There we go. See, that's so much easier. And we can even adjust the scale so that it's a little bit more brighter. We've done it. Not exactly. If we look at the UVs, like this is what our UVs, our face area mask looks like. This is not very helpful, at least not in this, what I'm going to be using it for, because the acne is going to be placed in a very flat projection area of the face, which is fine, I guess, but watch what happens when I put down another transform. And this time, I'm going to turn this guy onto its side. We're going to get like a silhouette. Okay, let's go back to cops. Now, this is very not useful, at least not for what I want to use it for creating the acne. I want to create the acne only on areas that I have identified using this face area mask. These points over here doesn't really help me all that much just because the areas don't align. This is just flattening it based on position. I need these dots to be based on UVs. And that's where I learned about this node. It's really just reading 2D points. So if we come back up here, instead of using this, instead of scattering points onto the 3D geometry, onto the head, I'm going to scatter points onto a 2D grid. And this is a 2x2 grid on the XY plane. So it's standing up. Now you really don't need to reverse it, but I just did it. I would have something nice to look at. Then I scattered random points on this grid. Yeah, let me break this out. Let me break this preview out. Make this a little larger. Okay, so these are the points in SOPs. Now let's go back to cops. We're gonna pull this. We're not gonna use this anymore. We're not gonna be using this guy anymore. We're gonna be pulling this. Let's go into cops. Now, this is the one that we need to modify. Instead of using points 2, I'm going to be using the original points that we had. And the viewport instantly updates. And look at this. Oh, let me get rid of the overlay. Oh, I think I have it flipped. These points should align like a 1-to-1 basis. They are the exact same points. I'm trying to line them up so that we can see it. So it means that this stamp point node is pulling in the points on and flattening it to a 2x2 grid. All the points that I scattered onto the grid are now in cops. Anything larger, it'll start clipping. So this is going to be the areas of the acne. but this is a grid. It has nothing to do with our character. Well, because this is still the UV square is still within this boundary. That is the part that's really useful. And we have a mask. We have this face area mask where I want the acne to appear. So I can use this to control where the dots appear. Let's get this onto our preview material so we can actually see the dots on the character model. We'll have a better idea that way, and then we can start tweaking the fall off and making it look a little bit more acne, something that we can use a little bit more usable before we start sending it off to Karma. Now let's see. Now if I take the stamp and directly feed it into the base color, this is just going to result in a lot of dots in all places, and that's not what I want, because I only want the dots to appear where I have the face mask. One really nice way of clipping all the other dots that I don't want using the mask that I created is just to multiply it. This works because our mask has the color white wherever we want the dots, and white is represented by 1, the value 1. Anything you multiply by 1 is just that value again. 10 times 1 is 10. So if you have a dot multiplied by 1, well, the dot will appear. However, the areas where I do not want dots are black. Like, I don't want acne to appear near the eye socket. So that area is black. Black is represented by 0. Anything multiplied by 0 is 0. So we'll never see dots in the black areas. By multiplying it, we can use this mask to clip out all the ones that we don't want. Clip out all the dots that we don't want right now. There we go. So now we have only dots in areas that we actually do want them. Then we plug this into the base mask, base color. Okay, so this works much better. Okay, now we can start tweaking the dots a bit. The acne needs to be a little bit bigger. Well, that was the style I chose. You can do anything to it you want to. What we want to do is, the shape here, it says square. I need a circle. It's actually clipping it. So the circle looks a little bit better. I don't know if you can even tell the difference. The square is clipping it on like a clipping edge, like here is a square clipping edge. The circle makes it a little bit more smooth. This is a little small. So let me up this to 2. Just because the acne will need to be a bit more apparent. And this masking is very sharp. So we're going to adjust this fall off. I'm going to max it out to have a nice fall off. So this is going to also double as a height mask. So we want the height to gradually grow, like a little bump. We don't want a sharp circle to plummet it all over, like a stamp that stamps all over it, even though that's what it's doing. It's a stamp point. We want that fall off. I'm going to create a null for a little bit more organization. This will make it easier to find this node in Karma when we're over there, so we don't have to keep flipping back and forth. Mask. Yeah, let's color it light red. Now let's feed this into the normal as well. Okay, that's huge. Just because this is a black and white value system. 1 is white, it maxes out the height, which works for masking image, but not for height data. How do we use this for height? Let's drop down a ramp. What we want to do is remap these colors to values, to height values that we can actually use. Drop down a ramp and remember to plug it into the position. Plug the other end to the height and render flag preview. Now here we can adjust it. Let's take this end over here and it's way too high. So let's lower this value. It's still too high, so we can 0.01. And this is a bit more reasonable, but it's still a little high for my taste. And the fall off doesn't seem, it's not as great. Well, let's see if we can blur it. So this is where we can start using the powers of cops to really manipulate everything. Okay, that's a bit better. It smoothed out that pointy part in the center. And now I can take the ramp and the highest value and bring it up just a bit. But there's something you need to notice. So when I did this, everything became bloated. Not only the acne areas, everything is bloated. Is not what we want. That means some of these black areas are not pure black. There's probably a bit of white that we cannot tell from this viewport, but a bit of white is showing up. What we can do is take this because we have a ramp, we can squeeze in that range and can really tweak it. Take this other end and I'm gonna drag it over so we can have a more precise black masking. There we go. And then, so it's at the 0.5 mark is what we want. And then take this guy and drag him down. Yeah, everything gets bloated, but that's not what we want. Okay, now let's make this smaller. Maybe even 8. Just a little bump. Yeah, okay. I'm starting to like this. You can play around with that. Just be gentle. Keep in mind that this is the height, so you need really, really small values. Depending on the size of your model too. If you have a really large model, then you'll need higher height values. You have to play around with this to find that sweet spot. Again, I'm going to drop down a null and write, no, what? All right, I don't know what happened. It just crashed. So luckily, I save often. So let's add that null again. It's going to be out, height. I'll give this a nice color. Okay, now these are the nodes, masking nodes that I'm going to be bringing into Karma, and we're going to do a render in Karma. Nice, more high quality render. Let's go back out here. I already have the LOP set up. This is working with the existing textures, the existing materials that I already set up. So we're only going to do something really, really simple just by model. Well, this actually has the acne because I already did it once. And we're going to reproduce this. Let me get rid of that background. This turned out pretty nicely. I'm going to show you how you can use that masking data that we generated in COPS and bring it into Karma and blend it with the existing material. We need to blend the normals, the height, and the diffuse and the color. So this is already done, but no worries. I have another one. So I'm just gonna copy this. And this is the one we're gonna be having fun with. I'm gonna come back up here though. I'm gonna find that head, and what I'm just doing is assigning it to the material that I just copied over, which does not have the black and white acne masking data that we created in COPS. So it just has the existing data. So we don't need this stuff. Let's isolate this for a minute because you don't want to see the other things. We're going to focus on bringing the COPS images into Karma. And I'm going to show you this. If you highlight a node that's already connected to the shader output in Karma and press X, this will isolate and just output whatever node that you selected is connected to this visualizer, and it'll output it right onto the viewport. Because this only has color, so it's doing a flat color paste onto the viewport. This is a great way to debug your material to see what's going on without any other noise, ignoring everything else. So we're just going to work with this for now, but it has to be connected to the output, the shader output. Now let's bring in our mask data that was generated in COP. So let's mtlx image, because it is an image. Well, it is a float because it's a black and white image, and we don't really have a file name. We have like a network name, so we can use the operator and then /obj/ character, and then this autocomplete is very handy. It was called COPNet. It was the COPNet 1 because COPNet 2 was the one that I created ahead of time. So COPNet 1 was the one that we were working on, and that's what I mean by putting a null and prefixing it with the out. It makes it easier to find when we're in Karma right now. We have a mask. I never did a color image or mask or this is the mask, but I never did a color image in COPS. And there was a reason for that. I prefer to re-ramp the colors in Karma rather than doing it in COPS. It's just much easier to change the colors because I don't want to keep flipping back and forth between the networks. Karma's the last stop, and fixing the colors is something you're going to be doing quite a lot up until the end. It's much better to have it in here, in my opinion. So this is the mask, and what we want to do is feed this guy into a ramp because we need color. This is black and white. We have a ramp. Now I want to actually see this, but we can't. If I connect this to the visualizer, nothing's going to happen because this is not connected to the rest of the network. It's just two standalone nodes. So we actually have to break the material just for a second, take all this and drag it over here. We'll drag it back. Okay, we see that because we're ramping it from black to white. Now let's take this and actually give it some color. I believe I made it green. So you take this guy over here and you make it green. I'll drag them down, and that's the white, and the lesser the gradient, the fall off is black. Well, I don't want that. Let's start with this. Let's give it something pinkish, but not really pink. I still want a bit of red to indicate a bit of swollenness. Now, right now, it's making everything red. Okay, so we have the pink to green. Now, the pink is bleeding everywhere. Not to worry. We do have a mask over here, so this is our mask data, and this will help us clip the pink areas. Let's start laying this on top of our existing color texture. So here is the original color texture. What I'm going to do is just another MTLX overlay, and we're going to overlay it on top of it. The background is the original color texture, and the foreground is whatever we're blending on top of it, and that's our acne colors. Now, this mix node is where we need to plug the mask data in here. This is perfect. And then we're going to take all this and connect it back over here, because this is what we want as the end result. And let's take a look. Okay, it's really flat right now because we haven't connected the height, but you can start to see now the pinkish red is not showing much on the ring on the bottom of it. This mask is doing a very good job of clipping that part. So what we can do is take this pink and move it over. There we go. I really like that ring, because it looks like it's swollen a bit, but the green is a little too strong. It's too bright. So I'm gonna lower this even more. So it's a little darker, and it's a little too green. In fact, move it over here on the color wheel. Pink is a little strong too, so I'm gonna move it closer to white on the color wheel. So you can really tweak this, but you're starting to see what I'm trying to get at. You'll really need to play around with this. Now first, I'm gonna color these nodes red, and I'm gonna delete this visualizer because we're not using it. Let's work on the height. So the height's over here. Displacement. Let's go MTLX image, and let's bring in the height data. That would be a float. And we're going to do the same thing. op:/obj/ character and copnet1 and then out. And this is our height data. Bring that in. The height. Now we can just plug it straight into it. We may need to adjust it a bit. Now that's not too bad. It's a little strong, but if this is what you're going for, it's not too bad. I think I'll keep it. If you really did want to adjust it, oh, actually, I will show you how to adjust it in Karma. We can drop down another ramp. Now this has to be a float ramp though. Let me connect this through. This is a vector, it's a black and white. We need it to be a float because the height data is a float data. So this way we can actually control the height and how it falls off. Now you can see that it's really strong now. Like it's a little spiky. I'm gonna take this a B-spline and B-spline. I'm trying to get a more smoother fall off. You have to be careful when you're stacking these ramps. Now, what do you mean by stacking? I only have one here. Well, we do have a ramp in cops as well. So that's accumulating the ramps, and it does sort of lower the strength of the height. So you gotta be careful with that. I'm kind of liked it how it was before. This is the part where I like adjusting the height in cops just because it's so much faster. Honestly, I kind of liked it how it was before, but I did want to demonstrate how you can manipulate the height again in Karma. You can drop down the ramp and then feed it in. I prefer not to do it in Karma, not the height, just because it does take a while to render. And you can see the height in the preview material in cops. And I think that works fine for me. I'm just going to ignore this and I'm going to use what we had before because I kind of liked what we had before. And I'm going to color these to red. Now we're done. No, we're not. We still have the normals. If you want a more crispier look, like a more realistic look, you need normals. Now we already have existing normals, and that's giving all this wrinkled pores and all this micro poly data that is coming from the skin. That's this guy. How do we lay our acne height on top of all this normal data? Well, first of all, we need this acne height needs to be converted. Let me put the X on it. Debug viewer. This needs to be converted into a normal data that we can read. Oh, right. This is not really connected, so we can't really see the height, the acne height, because this is connected to the displacement. This debugging tool only works if it's connected to this output shader. Even if it's connected to this displacement, it still won't work. Let's forget about that. But what we're going to do is convert this height data, which is a black and white color value. We're going to go height to normal. Just drop this down. This is perfect. So we need vectors. What a normal map is really just vectors. It's using the RGB channel values or using those channels to store the XYZ values. We need this to convert it into normals, and this is the normal map. We're gonna do that last. This is the normal data. This is the vector. Well, with normal maps, you always have a normal, like a node, to convert the normal, those vectors, into something that is actually a normal map that Karma can actually understand. This node is the last thing that goes into it. So this is the MTLX normal map. This one, which does the last conversion. This is the last thing that plugs into the MTLX standard normal. Just be aware this node connecting to that. Whatever we do has to be before this node. Let's take the original normals and combine it with our height, our acne converted height normal. We're just gonna use an MTLX overlay. You're gonna see that this overlay is used a lot because we're stacking images on top of each other. Now, the original normal will go to the background. The foreground will be our new acne normal. So that'll go over here. And the mix again will be our mask. And I'm not going to use this height data. I'm going to use our mask data. It's actually at the top here. We've already imported it here to drive the color. It's the same mask data. So I'm going to copy this. I'm going to paste it there. This will be drive the mixing. And then now this new normal will replace everything. Sorry, let me bring this up. So this is the red. This is the red. So these are the acne stuff. This is the original normal. Let me just even type it in. Original normals. And this is the, all this red stuff is the acne normal. Now let's see how it goes. You won't see too much of a difference just because the normal and the height is doing the same thing. So what we had before was pretty fine. This will give it a bit more quality. It will tell the Karma how to render the lights when it hits on it. So it does give it a bit more quality. It's a little hard to tell right now, but the specular over here especially, it's shining a lot nicer than what it was before, just because the lips, it's overlapping the lips a bit, and the lips, it has more specular. And those are the areas that will really make a difference when you combine, when you overlay the acne normal that was generated in COPS. Because normal maps just tell the renderer how the lights are reflecting on the surface. Thanks for watching and sticking to the end.